All right, everyone, let's go ahead and talk about density. Density is something that's very easy, and I think you'll see that it's not too bad, all right? So density happens to be an intensive physical property that relates mass and volume. Now, we haven't learned about intensive properties yet, but we will learn about them later. But essentially what an intensive property is something that does not change if you change the amount. So for example, a rock might be gray, like a gray rock. If you cut the rock in half and you get rid of half the rock, it's still gray. If you have a little bit of rock or a large amount of rock, it's still gray. And density is the same way. If you have a little piece of rock or a big piece of rock, the density will still be the same because it's a ratio of mass to volume. And we'll talk more about that later. But here's the equation for density. Density is equal to mass divided by volume. So if you have the mass and you have the volume, you can divide them to get the density. Now, the units that we typically use are grams per centimeter cubed or grams per milliliter. And as it turns out, a centimeter cubed is the same thing as a milliliter. And so these are the units that we typically use in this course. And so again, like I just said, a centimeter cubed is a milliliter. They happen to be the same exact thing, so they're interchangeable. Now, density is a physical property of a substance, and you can actually use it to identify the substance. And so substances have their own unique density. And so if something has, for example, the density of 5, it's definitely not gold because gold has a density somewhere around 13. And an object will float in water if it has a density that's less than the water. Now, the density of water happens to be 1 gram per milliliter. So the density of water is 1, which is kind of strange how it's exactly 1. Well, it's exactly 1 because we use water to define a lot of our measurements. So it's not a coincidence that it's exactly 1. Now, let's go ahead and ask ourselves then, again, remember, something will float if its density is less than water. So if water has a density of 1, that means that this will float because it has a density less than 1. Now, what about this? So will this float? It looks like it's pond scum. Well, it's got a density less than 1, so yes, it will float. Now, what about this? This is aluminum. It has a density of 2.7 grams per milliliter. Will that float? Well, the answer is no, it will not float because the density is greater than 1. In fact, it will sink. Now again, we can use density to identify a substance. Let's go ahead and think about these two balls here. Can we prove that these are the same ball? That they are the same material? Well, we'd have to do a lot of things to prove that, but there might be a way we can disprove it, because if they had different densities, then they're not the same. And so what's one way that we can see if they have different densities? Well, we can see if they both float or if they both sink. So let's go ahead and take a look here. So I've got this thing of water, this container of water, and I'm going to take this ball and I'm going to put it in, and look, it sinks. Now I'm going to take this ball and I'm going to put it in, and we're going to see if it sinks. Now if it does sink, it doesn't mean they're the same, but if this floats, it definitely means that they're different. So let's go ahead and take a look. And if you take a look, it actually does float. So somehow they're different. And this right here proves that they're different. Again, I want to reiterate that if they both sank, it would not prove that they're the same. It just shows that they could be. So that's it.